So the first thing I want to do here is make sure that I know exactly what angle I'm looking for, and I want to know what angles am I going to use to get that. So it says find angle DBC, which is this angle right here. So it's that angle in the corner right there. Now that is clearly not inside of a right triangle. But what I'm going to do is I'm going to find this red angle right here. And I'm going to find this blue angle right here. And then if I take the blue one and I subtract the red one, I'll end up with a yellow one. I'm going to go over here on the side. I'm going to do blue minus red equals yellow. Okay, so that's my plan. The right triangles that I'm going to use to get this out of, this shouldn't be that bad if we've done the other stuff. I've got that triangle right there, which is going to give me the right angle. And then I've got this triangle right here, which is going to give me the blue angle. So that's where my angles are going to come from. Okay, now, there's angles involved in the problem. So it's almost definitely going to be a SOHCAHTOA problem. And then I'm going to take each of these triangles, and I'm going to label the sides and figure out what to do with it. So I've got a hypotenuse here, I've got an opposite down here, and I've got an adjacent over here. So in the blue triangle, I know the hypotenuse and I know the adjacent. So since I know the hypotenuse and the adjacent, that's going to make this a cosine problem. So it's going to be cosine. The adjacent goes on top of the cosine, it's going to be 10. The hypotenuse goes in the bottom, and I don't know the angle. So in terms of length of problem, this is the best one because this is the only way I take the calculator. I hit second cosine, and it spits out cosine inverse. I put the 10 over 14 inside of the parentheses, and then that just gives me the angle I want. So 10 divided by 14 gives me 44.415. So 44.415, blah, blah, blah. That's the right angle. So I want to get the blue angle. That's coming from the green triangle. So in the green triangle, the hypotenuse is over here. The opposite of thinking again, blue angle, opposites down here. It's this whole side from here all the way over to here. I got to make sure I'm careful with that because that matters. And then the adjacent's up here. Now, what sides am I going to use? I have the hypotenuse and I have the adjacent with this. It is much more likely for this kind of a problem that you might end up using a different sine, cosine, tangent for each part because the sides are going to be different based on the triangles. Here it's the same because that's going to be cosine again. The 10 goes on top, the 16 goes on the bottom, the x is in parentheses. I'm looking for the angle, and whenever I'm looking for an angle, it's a second problem. So it's going to be cosine inverse 10 divided by 16. So second cosine 10 divided by 16. 51.317. And that's going to be my blue angle. And then in the very beginning, I said I was going to subtract those two to get it to give me the answer that I wanted. So go back to my calculator. I'll subtract these two angles. And I get 6.902. 6.902, blah, blah, blah. And it says to the nearest degree, so I round the 6 using the 9, which means I'm going to have a 7-degree angle there. Okay, now these should make reasonable sense. It shouldn't be a very big angle. But this is less work than the other ones that we did because there's no cross multiplying in any of these angles.